Seems like you have to flush it every couple of years.
Right. They just, every time we use it, it's different.
Water has to be solving something. Yeah, I guess all the way. I don't need a 50-90 video.
That's the thing.
Okay. We can look at the same. Spring, just like the shared screen.
That's just.
Anyway, we can work with that. Okay, guys, we're gonna get started.
Yeah, right. Mostly AMD.
Update on what Red Hat has come up with. AI integration in your
Right.
computer environment. So you can load different AIs up. So RamaLama, new name, something else to remember. So tell us again what we're looking at. RamaLama.
RamaLama. There we go.
It still comes out as audio. I have everything muted and so.
Yeah. All right, we'll do a little demo too live. We'll see if that works.
Audio.
Oh, is the audio not working? It sounds like it is.
The audio, I'm scumming through my computer. I'm trying to switch phone audio, audio. Audio.
Oh, there you go. Yep. There you go.
All right.
I think that's right.
That's better.
Can the people on the other side hear me? I assume.
There's only one other guy on the side.
Yeah.
I don't know if he's even listening.
All right, that's cool.
All right.
All right. How many of you have played with OpenAI, ChatGPT? No?
Yeah.
Little bit. All right. You haven't even said, tell me a story about a dwarf. Like type that in and then it tells you a crazy story. You haven't done anything like that? All right, we'll do some funny stuff here. But like, all right, but do you guys understand like these LLMs are these giant like models? Sometimes there are gigabytes and gigabytes, and you can either run one online, interact with it through like a website, or sometimes people download them and then you run them locally, and then you basically create what's called a chat bot, and you'll ask it questions and it'll do responses, and it's surprisingly realistic. You're like, this thing like knows a lot of things, although it's not always right. Yes, hallucinations. Yes. So we have this tool that makes it basically super easy to do this in one command. So you're on the command line, you go, I want to run this model. I type RamaLama run, give it the name of a model, and it just runs it. You don't have to do anything else. It'll even go find it and everything. It's kind of like Docker for models, basically. Buddy of mine at work, James Huang, is a product manager, so this is his presentation, but I'll give it to you. So, we kind of talk about it in this way. Like we want each of these things, right? We want a certain amount of excitement and a certain amount of fun. And so like excitement can be, too much excitement is bad, right? And not enough fun is bad. So we joke that we basically just want to make it boring. We just want to make it like you can download it, you can run it, that's it. Like it's very easy. Like I want to mess around with the model and talk with it and see what it's doing and see what it can do for me. See if it can generate images or talk to me or do whatever the model can do. But I don't really want to have to spend a bunch of time setting it up. So when you look at like Hugging Face, if you got to Hugging Face, it's very difficult to understand a lot of the models. Like there's this big repository called Hugging Face, And there's literally thousands and thousands of AI models out there. And you could sit out there for like 20 hours and still not know what you're doing, or know which one you should download or what you should do with them. So the idea is we just want to make it really boring. So what is RamaLama? We call it an easy, secure, and open way to run and serve LLMs. So there's two ways that you can consume LLMs. You can kind of turn them into a chat bot where you basically chat back and forth on a terminal, or you can create like a server and then the app can talk to it and like ask it questions through an API, and then it will respond to the API call. We call that inferencing. We call this is called inference. There's training when you're building the model, and there's inferencing when you run the model. And so this is all about running the model locally and inferencing and interacting with it. All right, I asked this, have you experimented with LLMs? Okay, so we have, at least Steve has. Have you run one locally? Has anyone run an LLM locally? All right, I'm going to show you how easy that is. Okay. Yeah. All right. So you've ran one locally. Yep.
How much memory do you need to run it locally?
Well, this is kind of a beast of a computer. I think this has 32 gigs, and it is a fairly beefy Core i7, but it runs okay. But even that will run like, generally, you're not going to run that fast on a CPU. You need a GPU if you really want to run it fast. But for just playing around, this is enough. You'll see. I'll demo it. How many have built an AI-powered application or built it into? No, we're not that far. All right. Okay, so give you an idea what this looks like. See this command at the bottom? You type RamaLama run DeepSeek. Has everyone heard of DeepSeek?
Yeah.
That was that model that came out that like raptured the world. Like everyone was like freaking out. So literally a couple days after that came out, I said to myself, I want to play with this thing. I literally typed RamaLama run DeepSeek, and I started interacting with it. I said, tell me a story about dwarves. Or actually, I said, tell me a story about Red Hat Enterprise Linux. And it like started typing up this like giant hero's journey of how this Linux saved the world and all this stuff. It was pretty funny. So I was like, all right, that's pretty cool. But I'll show you what's different about DeepSeek and what I learned from doing that. But it's really interesting because, all right, DeepSeek came out, right? The news article comes out. Everyone's like, oh man, the stock market crashes a little bit. Everybody's freaking out. And you go, all right, I don't want to sign up for DeepSeek. Like, I don't want to sign up at a Chinese website.
Yeah.
I don't want to like put my prompts in there and let them know what I want to type. I don't want to give them any information, but I wouldn't mind playing with a model just to see how it works. So the beautiful part about RamaLama is it pulls it down from DeepSeek, pulls the DeepSeek model down, I should say, runs it locally inside of a container, doesn't allow it to have network access. So it can't do anything wacky, can't connect back home, can't do anything weird. And then all of my prompts are locally. And so when I stop the LLM, it's all gone. It's ephemeral. There's no data loss. I didn't type my stuff into some Chinese website. I didn't give them data about who I am. I didn't give them prompt information about what I typed.
Is RamaLama available on Fedora?
Yes.
Okay.
Yes, absolutely. It's available on Fedora. It's available in Apple. And you can use it on Mac and Windows because if you have Podman Desktop, you can make it work with Podman Desktop.
Tried it with Rock.
I don't know what Rock is.
Rock.
Rock? No, I have not. That would be interesting. We can try that. If you want, we'll try it.
That'd be cool.
Yeah, let's see if that works. But the idea is it's easy to use, it's secure because it's a locally ran in a container, limited from the network, and it's also built on open standards. So it's totally uses regular containers. It can use Podman, it can use Docker, it uses OCI container images, it all uses open protocols. And what you'll find in this AI space is a bunch of companies are trying to lock you into their networks and things. This is just like it'll use any of them. It'll pull from Hugging Face, it'll pull from OLAMA, it'll pull from a regular container registry, it'll pull these models from anywhere and run them as a container or as a raw file. So pretty cool. So to give you an idea, it's built on a container engine. Like I said, Docker or Podman. There's a container image that has RamaLama in it, and it has something called Llama CPP in it, which is a runtime, which I won't even go into the details. But the idea here is that you can pull down these container images that have these libraries in them, like CUDA or ROCm or Vulkan. And so it is basically allows you to run the model in these frameworks. And then when you're done, you could basically build a container and push this thing off to a container image. So now you have the model and all the stuff, all the libraries and everything in a container image. So it's a lot easier to plumb into everything else that you do. So like if you're using Docker already or using Kubernetes already, you can just like once you've pulled this down and played with it in RamaLama, you can push it into Kubernetes. That's basically the idea, or into Docker or whatever. All right, so running the model. Let's show like a quick demo. Let me show. I think this is where he wants me to show you a quick demo. So let me see. Let me share my screen. I just want to. All right, so let's do this. So like RamaLama run. Oops, I keep doing the wrong thing there. Run DeepSeek -R1. Yeah, it's actually, you can actually out of. I should. What's the pull? This thing is 4 gigabyte. Darn it. Oh man. All right. All right. I got a different demo. Let's pivot. All right. Let's go back to the presentation. I've got a different demo here in a minute that I will then show. I know there's a place where he has a. I was going to show you a quick run of one, but let's do that in a minute. All right. So how does it do this? The short answer is it goes out and it searches like these different websites, like Hugging Face and RamaLama, and it'll basically search like based on one, like if you tell DeepSeek R1, it'll just find the default version of that and then it'll pull it down and run it. There's all these different branched versions. There's different quantizations, different parameter sizes, different alignment techniques. People do all these crazy things to these models to make them run in different ways. And then you'll have like, DeepSeek with a certain quantization, DeepSeek with a certain, parameter size. You'll see like, you'll see Llama 3.5 with 7 billion parameters or whatever, or 21 billion parameters or 400 billion parameters. So there's all these different branch versions, but you just want it to work. You just want to type a single name. The idea is this will find one that's pretty usable for anybody. And then from there, you can branch out and understand. But if you just go out to the Hugging Face site and search this, it's really a nightmare. Out of the box, it's super easy to use. It just uses a CPU. So it's not super fast, but it's good enough. It also has a minimum setup, and then it also has vendor specific setups that it will use for, like if you have an AMD card or a NVIDIA card, it basically RamaLama will run locally, detect what hardware you have, glue it together with a model, pull the right container for whatever hardware you have, and then run the whole thing together. So there's a lot happening on the back end, but it hides all that complexity from you. So you can basically just run a single command and it just works, which is really nice because I don't want to know what crazy software stack I need to build for NVIDIA or what crazy software stack I need to build for AMD. All right. So security and local containerized. We talked about like, why is that important? I don't want to go out and basically put my data on some website. I don't want to go to openai.com and then like type in all my prompts and then they have history of me for like 20 years of me typing what I've typed into that. Same with Google, right? Our Google searches are who we are. Anything you've ever searched on Google, they know that, right? Like we've all left a trail of tidbits of like our identity out there. Well, I think with the AI world, that gets a little bit even more scarier, right? Because you can basically start chatting back and forth with this. And it's essentially, you're almost interacting with it as if it's a human and they get to know you really well. So I'd much rather do that locally with a local model. And then when I shut it, it's done. It's gone. It's gone forever. I haven't leaked my data out anywhere. So, all right. So open, maximizing choice. So you'll find in this space, there's like some of these like name brand things, if you will, like Hugging Face and RamaLama. And the idea is that we want to give people choice. They can pull from any from RamaLama. They can pull. There's a bunch of other registries we want to add over time. They want to push or maybe pull it from one, to put it into a container, then push it to any Docker or container registry. That's what we think people want, knowing that from the container space. And then on the inferencing side, there's these runtimes that they pull the model down and run on top of. Llama CPP is one, LLM's one, Whisper CPP is another. Bunches of other runtimes. All these runtimes are good at different things. Some are good at running chatbots. Some are good at running image generation. Some are good at running audio identification. Some are good at sound generation. There's all these different crazy parts of AI stuff that are being built together today. And so like this is built so that it can basically run anything. It's built as a basic framework that can start to make any of these things easy. Today, it's mostly chatbots, but we're looking at doing RAG really easily. Basically, you handed a bunch of PDF documents, it'll turn it into a docling formatted thing, then push it into a vector database, then put the model on top of it. So when you ask it questions, the model will know information that is in your PDFs. Like if you have some like really, say you have a giant PDF library that is like about your product or about whatever you want, you then basically run the model on top of that and it will know the information in those PDFs. And that's pretty cool. So now instead of having to search the PDF, I can just chat with this chatbot and say, hey, what wattage does my, whatever generator run at? And it'll just know if it looks at the PDF, right? That's pretty cool. And that's a lot more accurate than just using LLMs based on like just the general training that a base model goes through. All right. So building an API, OpenAI, their REST API that everybody connects to at their service has become sort of the standard default API that everybody uses, even if you're running a software stack locally. And so basically what RamaLama Serve does is it creates an OpenAI API endpoint, and then you connect to that. So any tool, any piece of software, any Python library that knows how to talk to OpenAI can talk to basically an inference server running on RamaLama. So again, it uses super open standards, and there's a bazillion things that connect to this. Llama Stack, if you're not familiar with this other framework that is getting a bunch of traction. They're planning on integrating that too soon in the future. And as I mentioned before, it's really cool because once you run the model in RamaLama, you can basically fire it up. It fires up as a container, and then actually can export it as a quadlet. And if you don't know what a quadlet is like a special system D file basically that allows it to like fire up every time you boot the server. Pretty cool. So like if you want to say you want to have a DeepSeek R1 server running locally with that OpenAI API, you can basically just have it fire up every time you boot up the server, and now you've got this AI server basically that runs locally. If you want to put it into Kubernetes and schedule it, no problem. Like RamaLama will export either thing. So basically it can run as a local thing or it can go run in a Kubernetes cluster. So it makes it super easy. All right, now here's where I will run the actual demo. Let's see if this works. Dan has a demo where it is a much smaller model that will hopefully download easier. So let's see. Let me share this again. Oops. Let me go to this terminal. Hopefully this will work. All right. All right, let's try to run this locally. Thought I was in the. All right, let's do this again. RamaLama, CD into docs, CD into demo, and then let's run this RamaLama demo. So this is a standardized demo. So this is the RamaLama that I have. It's going to actually run the scripted demo, but it's actually going to use the RamaLama that's installed on my RHEL 9. This is a RHEL 9 box, the latest updates basically. Let's see if this works. I haven't tried it yet, so let's see. So RamaLama info. So if you do a RamaLama info, it will show you all these things about its configuration. A lot of the things you may recognize, C group manager, blah, blah, blah. It's telling you a bunch of stuff about how it's going to talk to Docker or Podman. It's telling you all kinds of stuff about what security controls it's going to use, how what cap settings in Linux. These are all basically container things that it's going to do, what kind of network it's going to use or whether it will use a network, what registries it will search. But I think the most important thing down here is to see, like, if you see it will search for images. This is where the RamaLama container is that has the runtime in it, and it will use llama.cpp as the runtime, and then it will store all the data here, and then it will run things in a container. And so I think that's probably the most important thing to understand, that it basically just runs containers. RamaLama is sort of a wrapper script that goes and talks to a container engine, pulls the model down from a model registry, pulls a container down with Podman, slaps it all together, and then stores your data locally, basically in a nutshell. All right, so let's get out of that. Let's clear this. All right, so this is a very small, it's called small m. It's a very small LLM, large language model. I think it's got 135 million parameters. The big ones have 400 billion. So this is a very small model compared to so they call it small m. And so when you run this, it's actually quite fast. it's quite spun down. Maybe not. I hope. It's up pretty on my side. It is, there we go. Yeah, for some reason this screen isn't updated, but mine is.
Yeah.
All right, there we go. All right, so it's downloaded. It's pulled the model. It's locally now. It's basically pulled the model from a model registry. It's running local, and then what we do is we show it. Hey, show me what models are local. And so you do an RamaLama LS, and you'll see it is pulled. When I handed it this small M135, it basically went out to OLAMA, which is a public registry for AI models, and it pulled down this model. And so you can see, if you pulled it from Hugging Face or OLAMA or a container registry, because it'll kind of tell you where it pulled it from. So it's pretty cool. Then you can see if you look Podman images, if you look, it's really just a container image that is RamaLama itself, the runtime. And then if you do a dry run here, we can see what'll happen. So basically what this is doing, it's a dry run, and RamaLama will tell you what Podman command it's going to run. So you see it's basically running a container, labeling it RamaLama, doing this security opt label disabled. It's naming it RamaLama this name. It's pull newest device. It's mounting some devices. And then it's pulling, it's basically mounting the I think the most important thing is it's mounting this model file, these model files in there, and it's pulling, it's basically doing the source and destination and mounting data basically. So it's basically just a container. It's basically running a container. It's a wrapper for a container that it's doing. And then if you look at this, it's showing that it's basically, oh yeah, that's cool. It's showing that it's basically showing that it pulled this from Quay.io. And then if you look at this one, it's showing, oh no, I think it died. I think it did not work. Let me see. Hold on. Let me see if I may have to update RamaLama. Let me do a quick check here. Oh, let's see. Still 0. Live troubleshooting.
Exciting.
Let's see. Did I install this through an RPM or did I download it? Nope, I didn't. So, all right, so let's download it off GitHub. Let's see. How do I install this on? Install on Fedora, Python 3. Let me do pip. Is it pip update? Maybe I did it through pip. You can install it a bunch of different ways. Let's try this. Pip help. See if this does anything. Yeah, let's try it this way. Let's see. That actually happens. Let's see. I don't know. I don't know what it made it hang out. That's not good. All right, that's different. I don't know. Let's see what happens. All right, that's different than before. And all right, clear. Pull that. Let's see if it pulls it. Should already be. What? Same version. Although I guess that it pulls the model down to a data place.
Well, it's kind of version of RamaLama, is it gonna
No,
wipe the environment when it starts a new
it
version?
may wipe it every time. I don't know. We'll see. All right, so let's see. Small M, ROM clear. Do the dry run. And why is it hanging? I don't know why. I don't even. I can't remember if I actually installed ROM. That's how bad this is. Because I may have just curled it. Yeah, yeah. Let me do this. I don't know why it's doing that. Hmm. Nope, still 7.2. Can we uninstall that one? Pip. Oops. Yeah, that's that one. So how do I delete a package? Down, install, uninstall. Hmm. That's not good. All right, well, it's gone. Well, I thought
It's called RamaLama.
I don't know what I just did. Let's see. Finish QA grep.
Says-
E. I think I might have just blown. Let's see. I'm assuming this is from Apple. Let's see if this works. Yes. All right, let's try this again. Now we should have a clean install, hopefully. No. I have no idea why. Why is it finding that version? I don't know. All right, let's try this. We're literally just gonna try. Try this again. There we go. All right, I've cleaned it up. All right. Let's see if this works. All right, we know this is 6-4. Let's see if this will pull this and actually run. Do try.
Oh, there's a small
Some some slow.
point image.
You know, primitive fusion.
So
One of those also
I know. It's frustrating. Okay, well, at least there we go. Worked. And it died. I don't know why that one dies. Oh, I'm curious. I'm gonna run this. I don't know why that demo's dying there. Yeah, see, it's not coming back with anything. Let's just do this. Let's do a full. Let's do a small m. Small. Let's do a small m. What is it? Small m 135. Nope.
It's 35.
Well, why is it not in my history? Why can't I see this? Ugh. Oh, that's why, because it deletes it every time.
Alibaba. What is it? Like,
Hmm. I don't know why it's doing that. Oh, I think it's two L's. There we go. All right, so it's gonna pull this.
So this is loading the yeah. Yeah, or is it?
Yeah, not a small 130. It's just a block that is the AI numbers in it. Weights and parameters that is. It's just all the way through. Guys, nothing big font weights and parameters. And you need to interpret it, right? Llama CPP or VLLM to interpret it. They do make it run speed it, make it run better things. Yeah.
Have you ever seen one guy series?
Pretty good. Yeah. Yeah.
Intuitive all the systems. Actually, the first thing correlation or between the parts of the data.
I don't know why this is so big.
The YouTuber guy is three blue, one brown. He's a mathematician. He's a PhD mathematician. He does YouTube channels.
Yeah, so it is what it is. So I'm stuck. For this, I want to see.
Look at it. I've just AI code. And I asked to go on to solve the chemistry problem. It's kind of complex, but mathematics. Yeah, and GP
Yeah, it does.
so I referred this with one of the other tools. Or Python to run.
Oh, there we go. I got it here. Rama run Deep Sea one. All right, this is pulling quite fast on my phone now. It's at least we could potentially see this thing actually get downloaded.
Yeah, there we go.
I probably shouldn't pull 5 gigabytes on my phone, but whatever. What is the point of having this 5G if I cannot do this?
Unlimited data. You should do.
Yeah, I think I do. All right, so it's now at 10%. That's pretty good. 11%.
Yeah, let's do it.
All right, we can actually get this to happen.
Okay.
This is actually happening at a reasonable speed. Now, if we BS for 5 minutes, it'll be downloaded. But
So when I was trying to get these AI engines to generate this piece of Python code,
yeah,
I was a little surprised. Claude immediately produced some Python code that would execute, but it produced answers that were like 10 times too large. And it's just obviously wrong.
the code.
The code produced numerical results. That were
Oh, so it wasn't working right
And
logically.
so I fed this back to it and it came up with, a long 2-page explanation of why it was. And then it produced new code, which was like half the values should have been.
It's not closer.
And it became obvious. I actually went through 14 iterations. It found guessed values that were in range, but I knew they were off by 10 to 15%.
Yeah.
It wasn't good. What it was doing is it was taking these half a dozen physical parameters and just tweaking them until it got something that was.
Approximately.
But it would produce this output and it would say, oh, well, here's a good sample output. And the numbers were perfectly correct, but then the code didn't produce that sample output. And I had the same experience with Grok and Claude.
Well, yeah, they all will probably do that. Yeah, because they're not good at math. Have you seen the way they do math?
Well, how
And then they lie to you about how they do
that?
math.
IBM and Oracle tell you that you should use AI to develop software.
Well, I think it can help you with a lot of syntax. So, there's two pieces to code, right? There's a syntax and then there's the, no, what do they call it? There's another name for the other part of it. Semantics, the semantics. The semantics, it's not going to get right. That's on you. But the syntax, it can help you a lot because it's really good at natural language. It's really good at natural language. It's really good at synthetically hallucinating. I don't know. So it's interesting. I have a 4-year-old and a 7-year-old. So, thank you. But the way that it learns is completely foreign. It's not how a human learns. But I will say, I watch my kids just guess shit. They just guess stuff until they get it right. We learn that in a certain way, that same way, yeah, trial and error. Well, we also just make shit up. Like my daughter would be like, yeah, Bob took the backpack. Like, what? Like that was syntactically correct, but the semantics made no friggin' sense. Like, what are we talking about? Like Bob took the backpack. Okay. Like, I don't know why she said it. I have no idea. It's like an LLM hallucinating. Like it's really good at the syntax, really bad at the semantics. Like little kids are the same way. Like it's hilarious. And then you realize the primates are not that different. Like the primate offspring are just showing it better than us, but we're doing the same shit. We just don't realize it. We're just kind of winging it. Yeah, we rationalize it and then we project meaning on it. And then I think we literally, I mean, I see this. My undergraduate was anthropology and computer science, so I see kind of both sides of this. Like we just project meaning onto it. And then you'll see, okay, it's interesting. I would even say among tech people, I see about 10, 20% of people, then when they start interacting with an LM, they're like, it's alive. Like they just literally have like this religious experience with it. they like believe it. Like, and you're like, this is not real. Like this is like just a made up, it's hallucinating stuff and saying it to you, right? Like, it's not even saying anything to you. It's just regurgitating tokens.
Yeah.
It's just tokens. It's just noises or symbols or pixels or whatever the output type is. It doesn't really know. It doesn't have any concept of what it's doing. Because when you ask it what it was doing, it tells you what you want to hear. It's like, what logic did you use to do that last thing? And it doesn't analyze what it did at all. It just says, oh, like, what did you, and it just looks, it goes, oh, it asked me a math question. Here's how you solve a math question. And then it tells you how a human would respond to that question because it's trained off a bunch of data, but it doesn't tell you what it did. It tells you what a human would say if you asked a human that question. Because it's just hallucinating.
Now, like perplexity, the police will show you the sources.
Yes, the one that's the Granite model that is used in Ansible's Lightspeed, it will show you the sources. So like if you're generating Ansible code, so there's something called Ansible Lightspeed, and these are the Granite model. It will show you what source code it was trained on. It cites the code, which is really nice. So you're like, even if it gets it a little wrong, you're like, okay, I kind of see what they were doing here, right? Like it gets you very close.
Yeah, but it's
The other thing that we found is when you constrain the inputs and the outputs, these models can get really good outputs. Like if you say, troubleshoot this Kubernetes cluster, and here are 3 commands you can run, check the man page, whatever. Basically, like it has access to man pages. You can put RAG in front of it. You can do this a whole bunch of different ways. But like basically in the gist, if you say, here are 3 commands you can use to troubleshoot what's wrong with this cluster. And it'll use those 3 commands like a mother to like try all kinds of different stuff. You got to make sure it doesn't crash your cluster trying to run a bunch of crap. But it'll try like crazy and it'll come back with a pretty damn good answer of like what's wrong. It'll solve it like 99.999% of the time. Like it's really accurate if you constrain the inputs. If you just tell it what's wrong with this cluster and then don't give it commands, it will F your cluster up. It will surely screw your cluster up. But if you tell it, if you constrain the inputs and say use these 3 commands to troubleshoot what's going on here, it'll figure it out. So, and it'll figure it out a lot faster than you would, if you're an uneducated, if you're like, I don't know, I don't even know anything about Kubernetes. I don't know how to troubleshoot. It's been years, it will help you. It's still very useful, but you have to constrain it like in a certain way. You can't just let it do anything. You have to constrain the inputs.
so one day they use these things where they say they're going to use it for code development or diagnosing human illness. It's like, do people really know what the limitations?
Those words could be perceived as true or false depending on how you look at it, right? Because if you constrain the inputs and you say, okay, here's a X-ray, analyze this, what's the most likely scenario? Like if you constrain the inputs and you go, is it this cancer, this cancer, this cancer? It'll probably get the right cancer if you give it 3 different kinds. And it's one of those 3, it's probably pretty damn good at that. But the doctor still has to tell it which 3. You constrain the inputs, right? So could it help diagnose? Yes. Is it going to do it by itself? No way. Like I just don't buy it. They're not, the way I've been wording it is it's level 2 self-driving. It's not level 5. It's not going to drive at night in the snow on a mountain. It's just not going to do that. But during the day, will it lower your stress level on a sunny day and you're on the expressway and it's a blue sky day? Yeah, it'll lower your stress level, but it's not going to like figure it all out. It's not going to solve every scenario itself.
So what's copying these blobs to another file?
That is downloading the RamaLama image now. It's decided to update both images, which is annoying, but it is what it is. So we've already downloaded 5 gigs on my phone. Why not download 6.5?
So this is actually RamaLama.
Yeah, this is the RamaLama runtime stack, which has Llama CPP in it.
So it's the executable.
Yeah, what people don't realize, there's a little script that runs locally, and then it pulls down a container image that has a bunch of other software in it, and it pulls down the model, and then it glues the model and that container image together and runs it. So it's a lot of software getting ran.
Yeah.
But it's very simple. And when you're on a network and it's fast, this happens in like 2 seconds. You don't even notice. But when you're on a phone, this takes a long time.
It's like better than on the old modems that we used to use.
Yeah.
300 baht.
Yeah.
Well, even
Look how jittery 5G is. It's like
yeah.
4 gigabytes, 25 gigabytes, 1 gigabyte, 2 or whatever, megabits per second.
Yeah.
Megabits per second are all over the place.
Yeah, they're jumping. Must be he's doing it by blocks or something.
Yeah.
It could be too, because the cellular network probably allocates time blocks for each person, so it like gives you bunch of bandwidth and all of a sudden it goes away.
Yeah, that's what I'm thinking. It's doing. It's close. Yeah, we're gonna get it, I think. Knock on wood, we're gonna be able to run AI soon. And then I'll be able to show you how this DeepSeek model works. It's pretty interesting.
Used to think, 150 megabytes would take it like-
Yeah, it works a lot better at home. All right, here we go. Come on, drum roll, drum roll. Come on, baby. I believe in you. All right, loading model. There we go. All right. So now notice we have a prompt.
Yeah.
Let's bring this guy up here so that you can actually see it. All right, this is probably even more visible. All right, so I will say, tell me a story about Red Hat Enterprise Linux. And it will say, think. It starts thinking. The DeepSeek model is a thinking model, basically, where what it does, people don't realize this, what it's doing is actually building up its own prompt. So it's basically generating a prompt first that it's then going to use to actually tell the story. And so it takes my prompt, generates an even bigger prompt, and then generates the story. So it's telling itself, well, what would a story do? Okay, first, remember that Red Hat is a company that's been around for a while. Started in the 90s, I think. They provide enterprise-grade Linux, which means it's more stable. Now, notice how slow these tokens are generated. It's more stable than Ubuntu and Debian. But often used in critical systems like banking, healthcare, and governments because it's known for its security and stability and security. It's going to go through and it's going to generate this whole thing. Now, mind you, it's generating these tokens fairly slow because it's running on a CPU, not running a hardware, accelerated. If you had an NVIDIA chip or something, it would use that and then it would fly through this. It would just, crush through these. But even at CPU speed, this is not bad. You can still see how it works and how it thinks.
Yeah.
I should probably outline the story with a beginning, a middle, and an end. Let's see. One, introduction. It's literally creating a prompt about the model was trained on how to tell stories. And so it does this thinking round first where it actually generates this big sophisticated prompt that then will generate the actual story. And so you see in this think phase, it does it.
Tell the same story?
No, it tells different stories. It tells different stories. It's statistical. Kind of, except that we've gotten really good with AI analyzing AI. So, no, my buddy's a professor at the University of Akron. They detect all the time when kids use this stuff for their stuff. It's like you're caught. The AI catches you faster than the professor can.
There's somebody.
They're getting so good at it that they can analyze the writing and know which model generated it.
Oh.
It'll be like, oh, this is generated with DeepSeek R1. This was generated with Llama 3.5, 40O or whatever, blah, blah. It knows which models. That's how good the AI analysis tools are. So it's an AI arms race. The students can generate whatever the hell they want, but the professors catch them like that.
Enter their own stuff in there, kind of throw that off.
Apparently not. It's pretty hard, apparently, my understanding. My buddy said they catch them all the time. The problem is every kid's doing it. And so it's like normally you get kicked out of college if you plagiarized. But now with this, that's actually the bigger problem is we're changing the cultural norm. Because they're not kicking kids out of college for doing this. They're just saying, no, you do this thing again or whatever.
It's like the old days, you either had to use a slide rule, but if you had a calculator, then that was cheating. Couldn't use a calculator.
Yeah.
So
It's kind of true.
we're kind of in that same phase again. You have new tools that work better and faster, and then the professors don't want you to use the new tools.
Okay, it's finally giving us an outline. Introduce the company and their problem with the current OS. Costs. It's generating this giant prompt. Jiminy Christmas. I don't know why it's going through a second outline. There you go. It's crazy. It's generating a second outline. It had this outline, and now it's generating the second outline.
It's not my favorite prompt. There's a lot you it's in 500 words. I just whatever in 500.
In 500 words. 500 words, I should do that. Oh my gosh.
Oh, yeah.
Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words. I should do that. Oh my gosh. 500 words.
Otherwise it runs amok like.
This is running amok. I've actually never seen it run amok like this. Oh, here we go. Wait, nope, I thought it was done. It's not.
Here's for example.
It's still thinking.
During migration.
RHCSA, RHCSB, I don't even know what that is. I think it just made that up. What?
That's why I have to explain it.
Red Hat Certified Systems Administrator, I think.
Yeah, well, it's RHCSB.
I don't know.
It's a better than a sysadmin. It's a sys, it's a B instead of an A. I think it literally just made that up. Like it's approximately right. You can see, but it's kind of crazy, right? Oh, here we go. Finally, a title. The smooth transition to RHEL. Oh, it's done with its thinking. See, it does the end of the thinking phase.
Oh, yeah.
So it's done with thinking, and now it's actually telling a story. In the bustling city of Tech Valley, there was a leading financial institution, Valley Bank, which has been relying on Microsoft Windows for years. As the digital transformation wave swept through the valley, Valley Bank began to recognize the need for a more robust and future-proof operating system. The current Windows environment was showing signs of age, with rising maintenance costs and increasing the risk of security breaches. Valley Bank's IT department, comprised of experts led by principal architect Alex Carter, faced a pivotal decision. They considered switching to Linux, but chose Red Hat Enterprise Linux due to its enterprise-grade stability and reliability. RHEL is renowned for its stability, blah, 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 blah. Like, it's hilarious. Tells really funny stories.
Yeah.
But like, you can tell it's been trained on the internet. This is a bunch of our very, this sounds a lot like Red Hat marketing.
Well, maybe that's where they're getting some of the money.
The migration process was no simple task. The team knew they had to address, now it's getting adventurous. Now's the adventure part.
Why is the GPU better than CPU for this? No, it's much faster,
They're much, much, much faster. Because it's a bunch of parallel computations, not one single serial computation. And so those GPUs can run like 40,000, I don't know, whatever, some crazy number of parallel computations.
So that's how they put up the graphics over.
Yeah, yeah. And that's why it's better at this kind of this is basically statistical stuff, so they're running a bunch of them all at the same time.
Yeah, it's a matrix.
Matrix math. That's that's the word I was looking for.
Yeah. Mm-hmm.
I can say the words matrix math. I have never done matrix math. I've never programmed anything with matrix math, so I don't have a good grasp on what it is.
That from class, we actually have to do hand calculations in matrices.
The benefits of switching to RHEL were profound. The bank experienced a 20% reduction in maintenance costs. Ooh, that's good. Improved disaster recovery capabilities and enhanced security with pre-deploy patches, whatever that is. The RHCSB component, I have no idea what that is, for instance, allowed them to migrate to a cloud-based storage environment optimized for the resources. I have no idea what that is. Red Hat cloud storage. I don't even know what that is. I don't.
Well, it's like kind of like a lot of folks. We can't douse you with the facts of that with the other stuff.
With RHCSA managing their storage infrastructure and RHCSB facilitating network virtualization, that's complete gibberish. That's complete gibberish. It just said RHCSB component, for instance, allowed them to migrate cloud-based storage environment. Now it says it's some network virtualization thing. Like, it's totally gibberish. I've never seen it generate those before, these acronyms, but Red Hat has a lot of acronyms. If you look at our website, there's a lot of acronyms. So it's something that looks kind of like what we would write.
Try to explain yourself.
I have found LLMs to be the most so it's done. There you go. So it told a whole story in what, maybe 5 minutes, running on a CPU with a bunch of tokens. I mean, it generated a ton of tokens. I mean, that's a lot of tokens. It took a while. On a GPU, that would have ran in like 1 second. But it took 5 minutes on a CPU. But this would never be good enough for an API call if you had an application. I wouldn't want to chat with something that's this slow, obviously. But you can kind of get the gist of, it can work. You can test out a model, see how it works.
So how do you go about putting, say you have just a bare bones Red Hat machine and you want to put RamaLama on that machine. What you use, or even for a Windows machine, I know that's available for Windows, it's for,
I think it's more about the GPU you get.
is it?
Yeah, it's way more about the GPU you get than the CPU.
Yeah, I mean, how do you go about installing,
Installing what?
RamaLama?
Well, I just installed it from Apple.
Yeah, okay,
Yeah, I just installed it from. That's what I just did here.
yeah.
I just did a Yum install from Apple.
Oh, just the young.
Yeah, you can also go to the RamaLama website. If you go to the RamaLama website here, I can share it. There's a bunch of ways to install RamaLama. So if you go to RamaLama, there's a whole bunch of ways to install it. You can install it on Fedora with just this command. You can install it from pip, and you can install it from the script. So if you're on anything, it'll just come out to. They basically go and compile a binary and put it, or it's a Python script anyway. They have the Python thing, and then you basically run this installer, and it'll run it. It'll install it. And these are the CPU hardware we have support for: Apple Silicon GPU, NVIDIA GPU, CUDA, AMD GPU with ROCm, Ascend with just regular. I don't know what that means, Linux. But you can get a couple different GPUs here, and these are the ones it supports.
If you don't have a GPU, it'll
give it a,
Falls back to CPU.
Can you characterize which GPUs are better?
I really don't know much about it, to be honest with you. I don't. I mean, I can tell you what there's a lot of politics in it that like all the engineers think, but I would say a lot of people are like, they want to build, they want to see a competitive ecosystem, and there's not one right now. I mean, NVIDIA's crushing everybody.
Well, wouldn't it basically come down to you want to get a GPU with the most memory? Because
it depends on what you're doing, but yeah, that's a big limiting factor for a lot of things.
it seems like, the memory.
If you want to run like a 400 billion parameter, it's all memory. But with this 7 billion, I'll bet it'll run on most things. My buddies have I don't know, they're like $1,000 cards they got. A couple of guys at work have been buying stuff build. People are getting back into building computers a little bit so they can get these GPUs and then play with this stuff. My buddy's been doing all kinds of experiments. Brian Smith, one guy at work, he's been doing all kinds of crazy experiments. Dude, he has done all kinds of things with image recognition and generation and all kinds of crazy stuff. You're like, this is incredible what it can do. Because one thing can generate them, another one can analyze them. And like he does all these like crazy demos where just all this crazy stuff where they interact in weird ways that I hadn't never thought about doing. Really cool stuff. He's definitely deep down the rat hole of just like learning it and all understanding it. Mine is mostly I've learned enough to like, I care more about how it's going to be useful to like an average person. I'm just kind of like, how will this be useful? Like I find it really useful to have it tell me stories. So like I was researching, I'll give you an example of something that I think is super critical, yet I still used AI to help me. So I bought a satellite communicator. So a year ago, as of like 2 weeks ago, I broke my leg. I have like 18 screws and 2 plates in this leg. And it's pretty good now. But I did a lot of physical therapy and a lot of working out to get it back. But I crashed on a motorcycle in Southeast Ohio by myself in March last year. It's like 40 degrees during the day. It was going to get down to 20s at night. I would have probably froze to death out there. And so I was like, oh, this is I just turned like a fun day into a life and death situation. This is awesome. Luckily, my cell phone worked, but I was only because I think I was up on this hill because I was out in the middle of nowhere. I mean, these is like some really remote areas down in Southeast Ohio. So I'm like, she's like, you're getting a satellite communicator. So I Google this and it's like, well, you need this and you need that and you need this. The satellite communicator is not enough. You need insurance. So I was like, oh my gosh, I don't even know what I need to like, if you dial the satellite communicator, it can be like 20 grand. You're like, okay, I want to live more than I want 20 grand, but I really don't want to spend 20 grand either. So there's like cheaper ways to do it, but you have to buy rescue insurance. And then you have to buy medevac insurance. And then you have to have a subscription for the. So it's like, all right, tell me a story about a guy that has a satellite communicator, but has no insurance. And he crashes in Nepal, blah, blah, blah. And it was really good at telling a story about how much money he had to pay and all these things. And the real takeaway is I asked it all these different permutations of the story. I was like, all right, so tell me a story about a guy that has travel insurance and has rescue medevac insurance and has a thing. And then it basically told me a story about a guy that did it and then didn't collect all the receipts, and there's a lot of fraud in this area, so you make sure you want to have all of your receipts when you have this insurance. I was like, oh, that's some good crap. That I like, think about how long I would have to scour the internet to figure that out. Like I would have scoured the internet for hours, and it told it to me in 20 seconds. So I was like, okay, if you interact with the AI the right way, it can tell you really rich information in really short amounts of time in a way that are different than search. But you have to think about it in a story kind of way, where you're like, tell me a story about a guy that got trapped with this device and not that insurance, or, you know, no insurance, but this device. And it was like, oh, you can be responsible for things up to 20. This guy was responsible for blah, blah. And, you know, it's really good at kind of scouring the internet and figuring out what these scenarios look like, but they're spread out all over the internet, and like search doesn't find that. But AI does find that because it's digested all of that data, and it's like in its neural network, right? Like, so like you can do interesting things if you know how to do, and that's very critical. I wanted to make sure I really knew what the hell would happen if I ever got trapped out in the middle of nowhere. What?
You put down 911?
You can't in Nepal when you're up near Everest. Yeah. So I rode motorcycles in Nepal in September, 6 months after I broke my leg. I was thinking I don't want to crash again and break my leg in the middle of nowhere. Definitely not by myself, and definitely not without a satellite communicator, not without medevac insurance, and not without rescue insurance. Oh, and by the way, they have an add-on. I found out that if you like get trapped in like Afghanistan and like ISIS decides to take over some neighborhood and you're trapped in a hotel, they'll send in former Navy SEALs to get you. It's like $300 a year. Not bad. Seems like a pretty good deal, honestly. Yeah, I found that out. That was pretty cool. So it's like 300 for the normal insurance and then 300 for the Navy SEAL add-on. I was like, give me the Navy SEAL add-on. I feel like, I don't know if I'll use that, but that feels like that's worth it. Yeah. Yeah.
Some crazy stuff.
Yeah, there's crazy capitalism. Gotta love it. There's some Navy SEAL out there that's like, God, I want to go back out. You know, they're just dying to go rescue some dude and, you know, wherever. I was like, that's me. Come get me. I'm in the hotel. I'm trapped. You know, like they'll come out with like a burqa, hide you. I'm like, oh yeah, I'm an old lady. You know, like get me out of there. You know, that's what I want. I want the Navy SEAls working for me.
Well, that's how they got the guy in charge of Nissan out of Japan.
Exactly. That's what I was like. I just need that. I need that team to work for me if I get trapped. You know.
Yeah, they hid him in a big.
You see, that couple got trapped in Iran. You're not getting out once the government gets you, though. You're screwed there.
No, but yeah.
British couple, they decided to go ride motorcycles in Iran. They took a picture of a sunrise, but the picture, I saw the picture, they took a picture of this power plant.
Oh.
And you know, it's just a piece of infrastructure to us, but they are like, they're spies, you know, and you're like, I wouldn't take a picture of anything if I was in Iran.
No.
I wouldn't really probably go to Iran, but but a lot, I'll tell you, I'm on the Horizons Unlimited website or on Facebook. People do it every day. British and American people do it.
Yeah.
There are hundreds of people that go through Iran and Syria and all kinds of crazy stuff. The only place people don't go is North Korea.
Well, Mel went.
Well, but that's on a very special thing. You're not going to just ride a motorcycle into North Korea.
No,
Yeah.
he was on-
But I mean, people ride through Syria, they ride through Iran, they ride through Kazakhstan, they ride through, I think Myanmar is one other place they won't ride through, like that place where the war is.
Oh.
You cannot ride through there. But basically, there's like, I would say there's a very small few places that you really can't go. But you have to be very careful what you do.
Yeah.
I did fly a drone in China by mistake. It's not legal.
Oh, did ya?
Yeah, I had the drone. I put it up, and then eventually it phoned home, and it was like, "You can't fly here," and it landed, and it wouldn't fly anymore for the whole rest of the trip.
Oh.
It was cut off.
It called home?
Yeah, it somehow got to the internet and phoned home, and then actually it didn't even have to get to the internet. It realized it somehow figured its shit out that it was in a no-fly area
Oh.
because it has all those maps loaded already in it. These drones are crazy now.
Yeah.
It was a DJI 4 Mini 4.
Mhm.
And it finally somehow figured out where it's at, and maybe the GPS figured out where it's at and realized it was in a no-fly zone
Mhm.
without it wasn't unlocked with a code that you get from the Chinese government. They have their FAA, and you basically got to apply for this thing, and then they give you a code and unlocks it.
Oh, I see.
But DJI has now said they're going to stop doing that.
Oh,
They're going to stop. They do it in the United States too, by the way.
yeah.
If it gets too close to an airport, it'll fly.
Oh.
It just won't fly. There's
Yeah.
all these no-fly areas in the United States
Yeah.
too.
Sure.
But they're not going to do that now.
I wonder why.
Because apparently a lot of these places, like people will get the code and it doesn't work right. And I read this article about it. There's all these like race conditions that happen where people actually are legally allowed to fly,
Yeah.
but the drone locks them out and prevents them from doing work
Oh,
and all this stuff. So they're basically like, all right, you guys are on your own. Figure out, if you get arrested, it's on
Yeah.
you.
Mhm.
So now we're back to flying drones wherever the hell we want. Like, but if I would have got caught in China, that would have probably been bad.
Yeah,
I might have been in one of those prisons.
yeah. Trying to get your
Luckily,
phone
it stopped
on.
after that, and then it let me. But I have some pretty sweet shots in the mountains in Tibet, dude. I flew over this area, and there were all these sheep, and there was this old Tibetan temple. It's a freaking sweet. Actually, I could show that video. It's a sweet video. Uh, let's see if I can find it real quick. Nope, that's not it. Let's see. It was before that.
Desktop doesn't show up on there.
I think I can figure it out. Oh, there it is. Hold on. Oh, this is killer. This is so crazy. I don't know if it'll show well on that or not, but will it do it?
There you go. Bill explodes.
Ugh. I don't know.
There you go.
You can see it here. These are incredible shots of the
It's on
drone.
the screen. Wow.
Yeah, but
It's not fast enough to.
Yeah, it's not fast enough to show it. Can you see that? I mean, how crazy that? Yeah.
Well,
Yeah. Here, plug in the cable. It's pretty incredible. I'm glad I got a couple shots before I got shut down. Nope, that's not that. There it is.